Hi everyone, and welcome to today's presentation on Protostructure 2025. I'm Nigel Watts, Managing Director for Prota based in Asia, and it's my pleasure to host you in this event today. I'm going to take you through many of the new features that we have in the new version. It's been quite a quick turnaround in releases from the 24 to 25 release, and there's a lot of quite exciting ground to cover. I'm not going to go through today so much of the feature list. We've prepared and presented that in previous releases, but today what I really want to do is show you the new version in action. Okay, so thanks for coming. I'm just going to turn my camera off for a minute and then give you a little bit of background on Prota, and then we're going to dive straight into the software. So I'm looking forward to showing it to you. It's been a quite exciting development with the 25 release, and we'll go through it over the course of the next hour or so, and I'll introduce you to many of the new functionalities. Okay, so let's get into it. I'm just going to start by just giving you a little bit of background on Prota. I think you know, as a business, we've been growing globally, and we are in something like getting on for 100 countries around the world now, and we have tended to focus on specific markets and tailoring the software to suit your local requirements. So you'll notice that not only do we support major codes of practice, but we've also gone and refined the solutions to suit specifically your local requirements. Okay, so wherever you are, whether you're in India, whether you're in Europe, you're out here in Southeast Asia, or you're in South America, we've done a lot of work to customize and localize the software to suit your requirements, and that's really enabling us to grow. Now, just some background: we've been developing technology since 1992, where we created the world's first design detailing system, Orion, and that was very successful around the world. We also have been involved not just with software development, but also looking at existing infrastructure and how do we upgrade and retrofit that, particularly after or to adopt a new seismic codes of practice and changes in building regulations. Often infrastructure needs to be reviewed, and we have developed some specialized tools in this area to help. We started communicating with Revit physical models back and forward in 2007, so it seems like a long time ago now, almost. Wow, we're getting on for 18 years. So we've been at the forefront of sort of modeling technology, physical modeling technology, for many years now. We redeveloped the platform in 2014, and this is where Protostructure was born, and it's evolved tremendously over the 10 years since, and you're going to see a continued evolution in this presentation today. Not to be outdone, we also have a very successful engineering team that's based in Istanbul, and they've been involved in some world's first. The largest international airport in the world was delivered in Protostructure using the technologies that were developed together with a lot of the high-end seismic capabilities we have in the platform as well. And as I mentioned, we're growing globally, so we're almost at 100 countries around the world. Almost, not quite. We just need a few more sales in some new countries, and we'll crack the 100. So now, to do this, we invest significant time in the development of the platform, and that covers language support, detailed technical guides, a range of different international codes, and we also have a partner network that we support in delivering the technology locally to countries all over the world. And we have a fantastic growing user base. It's really great to see the interaction that we get with our client base. Now, what's the philosophy behind what we're doing? I think this is very important, just so you understand how we differentiate ourselves from others and what's important to us as a business. So obviously we look at what engineers are doing in practice and the type of solutions that they're using, and many of you have general analysis programs to model and analyze different requirements, and there's lots of different programs out there, STAAD and SAP and so on. Now these tend to do some design, but they often don't do a lot of the detailed technical design that you need to complete a project. So if you're having to check things like lap lengths and anchorages and connection design and foundation pile caps, pile design. So a lot of these things require extra tools to enable you to complete the job, and often you might be using other little components to help you with this, and there's lots of different programs out there that do that. And then once you've done all this, you're then bringing this all together and often drafting it up in CAD, and often these are generic CAD platforms, AutoCAD and the like, that are set up for generalized drafting. Often they're not really tailored to suit what structural detailers or structural designers need. Okay, and they're really just a way of communicating the information, but from scratch. Then if you're getting into fabrication, again, there's different tool sets. So there's Tekla Structures and BoCAD, and there's other systems out there that would enable you to provide this level of information. And then finally, if you're wanting to share and coordinate projects, we've got probably the elephant in the room is Revit, and there's other programs like Archicad and the like. So what we normally typically see around most engineering offices is they've got lots of different solutions that they're using to help them deliver their projects. But often these solutions don't talk to one another. So all the information that you have is kept in silos. So you might have done the modeling and design, but then you're having to sketch it up and pass it to a draftsman to draw up. And then if you need a BIM model, maybe you're having to start that whole process again from scratch. So we're seeing that a lot of the information doesn't flow naturally between these different stages of design. We also obviously see that you're using lots of different programs with lots of different interfaces that you've got to learn. And obviously there's the investment in learning these platforms and time, but also obviously the financial investment. So when we look at this, we just see this as all being rather disjointed and not seamless in the way in which a new modern software should be working. So what we've done is created a dedicated solution for modeling and analysis, streamlined for buildings. We can design everything from the roof down to the foundations, and specialist treatment for things like core walls, pile caps, steel connections, all the things that you typically need to design within your project. Once we've done that, we then have look at a dedicated platform for producing all your drawings, organising them all nice and neatly into your title blocks, arranging everything for you. Okay, so that's all seamless and nicely presented for you for your documentation. Okay, but a system that's also set up for structural detailing and has tools within it to enable you to edit, make changes, add other details, add other little design components, macros, and so on. A tool that enables you even to go fully down to fabrication. So increasingly we're seeing more and more engineers who are looking at design build or design construct, and they're being asked to go that extra step in providing this level of information. And as the technology is evolving, this process is becoming increasingly seamless, and we're looking at providing you this kind of information at your fingertips. And finally, a structural BIM platform, a physical model that allows you to share and communicate all of this with other BIM platforms to be able to coordinate projects with your clients, the architects, the owners, before these projects get off the ground. So modeling, analysis, design, fabrication, detailing, fabrication, and BIM. Now what we've done is just create this in one singular system, ProtoStructure suite. Okay, and there's just one solution for all your needs. Essential to this is ProtoStructure. You can build your models in here very quickly, perform the analysis and design. ProtoDetails is our general drafting tool, allows you to lay out everything into your drawing sheets automatically. You can draft in it. It's full DWG capable. You can add extra details. You can go right down to providing shot detailing as well if required. ProtoSteel allows us to design our steelwork connections and go right down to assembly drawings, part drawings, and general engineering drawings, connection details, all that type of thing in there as well. And our ProtoBIM is our enabler, so this enables us to connect with a variety of other platforms, whether it's Revit, whether you want to send a model out to SAP, whether you want to communicate directly into CAD. Protobim is the technology that allows us to connect you with others in the industry. And the software is being used across industry. We see it being employed on a range of interesting jobs around the world, from huge airports to large university educational campuses. We see mixed-use developments, different structural systems being employed, flat slab, slab wall, transfer plates and the like. We see multi-story commercial residential developments. We see a lot of people doing seismic design, retrofitting, building assessment. We see airports. We see a range of different structures, steelwork, industrial buildings. Really interesting, simple and complex projects that are being delivered in the technology. We even get the pleasure of designing the odd palace. So this is the Astana, which is the national King's Palace in Malaysia. So that was designed in the software as well. So it's a really eclectic mix of interesting projects that we see our users getting involved with. So enough background and talk. I want to just jump straight into the platform today and take you through the software. I'm just going to come out and we're going to dive straight into this now. So I'm going to launch Protostructure, and today I'm going to take you through a range of different capabilities that we've introduced with this release. I'm going to try and do this as succinctly as I can. We're going to cover a bit of ground, and hopefully I'm going to be doing something a little bit new today. So if I have a hiccup at all, please forgive me. But I'm going to take you through this relatively quickly. You can see some of the new capabilities that we've introduced in the platform. Now, these are documented, so there's what's new systems in here. If you're an existing user, the Help Centre's got a new chatbot. You can ask it questions. It'll try and direct you to the right articles, right information to get the most out of the system. Of course, we have our YouTube channel. Please check that out. We're constantly adding new videos and videos and discussions there. So please subscribe and get all the latest news from us. Now I'm going to create a new project, okay, and we're going to call this event 2025 NW. Now you'll notice that there's a lot of templates here. You can grab a template. Now these are customized to suit local requirements for the chosen code of practice. So if I choose, for example, a Eurocode template, it will load the local settings to the Eurocode for that country. And we've covered a range of different countries here all over the world, whether you're in the US, the UK, whether you're in my part of the world, Singapore or Malaysia, Thailand, or you're over in South America. We've customized the software to suit your specific local requirements, and that includes language as well as local design and detailing practice. So when you choose these settings, if you're in India, for example, it will load the local Indian codes, load all the local material databases, all the local way of design and detailing will be performed. Okay, so this just saves you a lot of time with having to set this up. So I'm going to design something today to Eurocode. Okay, and I'm just going to choose this. This won't affect the way in which you generally model in the software. Okay, that's all rather standardized. But I'm just moving straight into the modeling environment here. So here you can see we've got a grid. Across the left we have our tree. This is evolved, so you'll see if you're an existing user that we've added a few extra settings in here, things like sheetings and studs for composite and so on is all new. Okay, you'll see that this ribbon's evolving as we develop it further. For those who are new to the platform, it's quite straightforward. Here you can start with different information that you have available to you. Perhaps you just have architectural plans, or maybe you've got some 3D physical information that you want to take advantage of. You can bring this in here. You can then work with your modeling, so you can model your concrete and steel work. You can assign loads, seismic, wind, and so on. You can check things before you get into the analysis and the design. Okay, you can design your concrete and steelwork here. You You can then produce all your drawings, okay, whether it's concrete steelwork, as well as sharing and communicating this information with other BIM platforms. Okay, so if you wanted to send a model to ETABS, or maybe you want to create an IFC file, all of this is seamlessly done in this interface. Okay, so that's logically laid out here. Now I'm going to, for the purposes of this presentation today, create a simple model. I'm going to just come in and draw out some axes, okay, and just going to create a really fairly regular grid here. And with this grid, I can take advantage of things like offset axes and so on to create extra intermediate grids. So I'm going to just key in a grid line here, and I'm going to just take this grid and I'm going to cut it down. So we can do things like stretch the axes. So if you just want to bring an axis in a little bit, and maybe the bottom one here, I just want to stretch that up, okay, to a position. Okay, maybe I'll just tidy that up a little bit at the top there. I like it to look good. Okay. Now these grids are all customizable, so if you don't want to see grids or you want to hide them, you can. They don't need to be present in the model, so I've just hidden that axis. I can also take these grids and I can offset them. So if I wanted to create another grid, say 10 meters away, I can just type that in and I can create that. Now you can use the grids to help you with set out, so a little bit like sketch lines. And again, I can hide these and I can just use the grids as I'm doing here, just to sketch out positions that I may want to model to. Okay, these can easily be done here. So I'm just here. You can see I'm taking advantage of the grid, the background grid as well with that set out. Okay. Now at this point, I'm going to use those to actually create some walls. So I'm going to use this to just model and create a core wall. So I'm just putting the properties in here, and you can see I'm just running around and setting out a core wall. Okay, and I'm using those axes just to help me define that. So I'm putting a wall in at this location and just running around and setting that up as I'm doing here. Okay, so that's, you can see that I've created a C sort of a channel shape core wall. You can have any type of core wall shape you like in here that can easily be defined. The next thing I'd like to set up is some columns. So I'm just going to put in a regular arrangement of columns. Let's call these 450 square. Okay, we can box around to put them in quickly, okay, and define them as I've done here. I'm just going to run around, create these around the periphery, okay, and we can come and set those up. Next step might be to provide some beams, okay, and I'm just going to define and set up some RC beams. Okay, you can just give them some properties here. Now these can be quickly defined. You can just, if you have a regular arrangement, you can just box around and with a click and create everything in one shot. Okay, now at this point, before we get into creating slabs, okay, it will ask us to define our load combinations. So we have a new load combination generator in the 2025 version, and it can guide you through the preparation of standard combinations in here. I can set up my dead and live load cases. I can set up a few permutations with things like pattern loading, stage construction, thermal cases, lateral cases like seismic can be set up here. You can, if you wish, model vertical seismic. This is something new that we've added. Wind loading can be set up. You can assign notional loads to that, or you can leave it. You can generate separate combinations for steel as well as concrete. You can also add geometric imperfections for this. Maybe on the job you've also got a basement, you want to assign soil pressures. All these types of things can be easily defined and done in the model. Okay, so if I just accept that, you can see it's generated all these cases. Now you can add other load cases to this, so it's fully flexible. If you wanted to add a crane beam case or something like that, it's easy to come in here and set this up. So here I've got my concrete, my steel cases. We also have new separated out the serviceability cases here. So you can have different serviceability checks for steel as well as concrete here. Okay, if you're happy with that, then you can accept this. I'm now going to come in and define my slab. Now you can key in a thickness. Okay, I'm going to define some dead and live load. If you're not sure, there's tables here that you can refer to quickly establish them. So if it was say 2, for example. Now, if I click on the insert slabs automatically command, it will just place all those slabs automatically into that defined area. So they've just been quickly set up, and I'm just going to remove the slabs at the core walls there to make that clear and easy. So what I've done at this stage is just create that first story level here. Okay, and you can visualize this. Okay, at the moment I've got I've been working in plan, but what I've actually been doing is creating a 3D physical model, and you can see the start or the beginning of the model that I'm about to build. Okay, so we can tile these. Okay, and you can quickly come and set these up. Now what I'd like to do today is I'm going to work with some different structural systems from what we might typically work with. So I'm going to come and insert some stories. So let's assume that this building is 4 stories high. And I'm going to take that first story and I'm going to generate some information up. Okay, so I'm going to take the first story and I'm going to copy it to the second. But I'm going to remove the beams. I don't want the beams at the second floor level there. In fact, what I want to do is adopt this as a flat slab. Okay, so if I hit OK, you'll see that we've now generated that up. You'll notice that the slabs look like the beams are missing there. Okay, that can easily be resolved. So if we just hit move members to axes, okay, that will then remove those. Okay, and you can see that that's just regenerated as a flat panel. Okay, so we can come in here and establish this kind of arrangement. What I'd also like to do, and maybe what I'll do is I'll focus on the, I'm going to just focus on the plan view for the time being. So let me just move into that. What I'm going to do at this point is come in and define another slab. Now I've put the slab in at this point as 200. I'm just going to quickly change this. Let's assume that the slab is going to be 250 thick. Now, to do this, anytime in the software, you can select the elements, you can go down to slab table, you can easily come and define and make changes in here. So if I want to just quickly change the slab, a bit like in a tabular format, I can quickly change, and this could be other things, loadings and so on. Easily you can come in and make changes. So I've increased the thickness here to 250. I'm also going to want to create another type of slab. I'm going to assume that my slab is I've got a cantilever to it. Okay, I can define the thickness again. Loading again, we can just put this in. It'll be 1 and 2, but I also may have I've got a cantilever, so I'm going to assume that this is going to cantilever out a bit. And I also want to have a parapet load, so I could define a small parapet around the edge of that. It could be a balcony, railing, or something like this. Okay, and to define this, I can just clues between margins. Notice how it's asking me which side I want the slab on, so I can just click and create that. Okay, so I'm just running around coding that at the edge there. Let's run around and put this one in as well. Okay, and finally this final side. Okay, you'll notice that it's joined at the corners there. Okay, to create this this panel. Okay. Similarly, if you select all the elements, you can just easily come and filter. So if I just filter the selection, maybe I just want to see the columns, and I'm just going to select the columns only, and you'll see that they've now been highlighted. Now at this point, I'm going to come into the column and I'm going to insert a new function here called drop or slab patch panel. Okay, now when I select this, it will then allow me to define a drop head panel. Now you can key in the size of this. I'm going to go for a 200 by 200 panel. I'm going to make it a bit thicker. I'm going to make it about 350 thick. I'm also going to set up some patches. Okay, now these patches are something new that we've introduced in the 2025 version, and it allows us to integrate across these patch widths for the design and detailing of the flat slab. So we're going to average moments across these widths. We can define the patch layouts here. If I hit OK, you can see that straight away we've set those up, okay, and they've been established in the model. Okay, you can do the same thickenings around the core wall. I won't do it for this example, but those can be done as well. So here you can see that I've set those drop head panels up. okay, together with our the drop head panels, together with the patch zones. Okay. Now, if I just go back to the plan, what we would want to do with designing the slab is we want to set up strips to allow us to integrate across strip widths. And you can see here, I'm going to define some slab strips. I'm going to choose the direction I want the strip in. I'm going to go for a finite element strip, and I'm going to use an integral strip. Now, I'm going to draw the results from the building analysis, but you could choose just to do a subframe analysis. It could just be a FE4 analysis in here, and you can also define the width over which you want to integrate. Okay, so I'm now going to define these strips, and I can just draw through the slab here. Okay, and you can see that I'm just coming in and defining the zones over which I want to create these strips. Okay, and you could just easily put these in, and you can define where you want these strips. So these are, I guess you'd call them mid-band strips. I can cut strips in the other direction as well. Okay, so if we just come up, and I'm just creating them in the Y now. Okay, and we can just carry on and draw these through. Okay, another one there. Okay, another one maybe here. Okay, and we can carry on and just draw these through. So when we run the analysis, we're going to mesh this floor, and it will then collect the forces along these zones for the design. So the patches we've created, okay, and I think I've just made one that's not quite what I would like. I can just go back and reposition that. Okay, let's just get that orthogonal. What we're doing is that I have a strip here, and if I was looking along this strip, I've got a patch here, I've got a mid-band, I've got a patch, I've got a mid-band, I've got a patch again, I've got a small band, I've got a final patch. So we're going to cut a FE strip along this, it'll integrate along those strips, and then it will design the steel, it'll average across those widths and design the steel in those zones. Okay, now you can set up other strips, intermediate strips as well. So if I wanted to define another strip, and it could be a strip along this mid-band zone. Okay, you can come and choose this, and you'll notice here that the width here is editable, so you can choose the width over which you want the strip to integrate. So I've extended that width across this width here. Okay, and I could at the same time cut the same strip in the other direction. So let's assume that we are cutting a strip here as well. Okay, and I could carry on. I could break this all into for the whole slab. But I'm just going to give you an idea of how that's set up and how you can go about using this. And later on, it'll collect all those forces, and then it'll automatically design the slab for you. Okay. Now, as part of this process, let me just say this, as part of this process, you may also want to just look at the loading, okay, and the software will predefine different pattern load variations for the slab. So when I set up the pattern loading, you can see that it's defined a series of different permutations here. Okay, now you can manipulate these if you wish. So if you didn't like this permutation, you could turn this panel on and off. Okay, you can just come around and you can manipulate this to suit the different permutations that you would like to see. So if you wanted to have, I don't know, something like that, okay, you can set up a checkerboard of different type of loading that you would want to see in the slab. Okay, so this can be up to you, and you can set up these different permutations. There can be really an infinite number of different permutations that you could establish here, but this will then cover the range of expected loading that you would expect on the flat slab. So the pattern loading will then resolve it into envelopes that we will then use for design for the slab system. So this is a nice, easy way to see that visually. Okay, and of course, as I mentioned, you can work with this to manipulate it to suit what it is that you want to see. Okay, okay, and you can create up multiple different. You can add to these if you wish, and set up all these different cases. So it's a nice way to visualize that. Okay, so we've set up this this level, okay, with a flat slab. I'm going to now go up one more level. So let's I'm just going to go back to our stories again, and I'm going to generate up. So I'm going to take this the second story, and I'm going to create the third story. Now this time around, I just want to copy the columns and the shear walls. So this is all I'm going to take up the building. Okay. When I do that, okay, you'll notice that it's also drawn the taken the column heads. Again, I could just filter these out, and I'll just quickly let's just quickly just isolate those, and then if I come back in, I can turn off the drop head panels so they can just be removed. Okay, and I've just got my columns left. Okay, so if you look at this in 3D, you can see what I've done here. I've just extended those columns up. Okay, if I'm going to go back to this plan, this time round I want to model something a little bit different. This time round I'm going to create a composite system. Okay, and to do that, if you come to the steel menu, you'll see that there's now this new option to create frames. So the frame members cover a range of different uses. It could be just general steel members, it could be purlins and girts and bracing, but we also have this new frame element as well, frame group element, which I'll get to. Now I'm going to create a primary composite beam. So this is new. You can just select this option, and in here you can come and choose from different databases. So a section. So I might want to use a UK section. Okay. I can come and look at the sections and choose something that I might think is appropriate. Okay, for this, let's use a 45 kilogram per metre section. Okay, a British section. I've had okay, I can accept that. Now you can play with the fixities, so I can have this either, primary beams can either be continuous or they can be pinned. Okay, so it's up to you. Typically with composite, you're wanting to pin things. Okay, you don't want onerous connections, so we're going to just pin these, and again you can just box around to create those members. Okay, like I'm doing here, I'm just creating those primary members along the beams. Okay, you can of course snap to points. Okay, which I'm doing. I'm just going to quickly come and create. Okay, let's come down here. Okay, maybe I'll do the same thing here. Okay, I'm just going to model that. It's, because I've got these walls here, I've got the flanges on them, I want to make sure the connections there are made properly. Okay, and then again we can just put in our primary members here as well. Okay, so you can see quickly I've established some primary elements. Okay, now at this point I'm going to take these primary beams and I'm going to add my secondary members. So to do that, and I want to do this quickly, so to do that I'm going to choose this option called frame group. Okay, now in the frame group I can come and choose another section. So again, this would just be maybe a secondary composite beam, and you can choose the nature of the item that you're modelling here, but I'm going to use a secondary composite beam. Okay, I can choose the number of members I want to have in here, and I can choose where I'd like these placed. So I'm going to just position them between these two members. Okay, and we've the first member there, second, third, so on. And I'm just going to come and model these across the thing here. Let me just go back and load the properties. I'm just going to choose the members there, and you can see that we're just quickly placing these across the model. Okay, so I'm just choosing elements that I'd like them to span between, and they're getting created. So quite quickly I can set these out. Okay, I'm just coming in and running around and placing these members. Okay, that bottom one there, I'll come back to it in a minute. Let's change that now, so I can just normal and update, and you can see that that extra member's been added there. Okay, and I guess that will be the same for this one as well. Okay. And it'll probably be the same for this one also. Okay, so quickly we can come and set these out. Now let's finish this off. So to do the first member again and go back and just finish these. Okay, and here I'm going to do it in reverse. So I'm going to delete the last member. So I'm going to just place these ones here. So very quickly you can see that I'm able to frame this floor out just by taking advantage of this. Now you can also, you'll see I've got some areas that I haven't yet created here. So I'm just going to go back and finish this, and I can just come in and create the secondary beams myself. So again, I'll just choose the same section. Okay, let's do that, and I can just model these in myself. So I can click and create. Okay, we've got some really comprehensive copy commands in this in the new Steelwork as well. So if you want to quickly copy things and paste them, you can do that as well. Okay, I'm just going to quickly just run around and add these extra members in. Okay, so you can. You can be very as accurate as you wish here. I'm just running around and creating what I would think to be a sensible arrangement. Okay, and okay, oops, I think I've gone too far with that member. Please, let's just, I think I missed a snap point there. Let's just come and create that. Okay, and then it's just, okay, so just finish this off. Okay, all right, so I've created an arrangement here that is at this point just a frame. So if you come to the 3D view, you'll just see that that's a frame. I'm going to go back to the main view, and what I want to do now is define a composite deck. So to do this, we will select 2 points, okay, and I'm going to select these points here, and it will then prepare and preview what the composite deck might look like. Now there are different types of decking arrangements here, so you can have the deck flush with the top of the flange, or you can have it sitting above the flange, which I guess is what most systems will be like. So you'll see when it does this, it's automatically looking at the effective widths and calculating them. But you will now have to go through and define a series of inputs for the design. So you'll define a fabric, you'll put in the depth of the slab. You'll also define a construction stage, and we will run the construction stage as part of the analysis. Okay, you can put in the dead load. You can also put in a live load here. So you can just define these in here. Now, the last thing you're going to look at is maybe the decking system. So we've got a range of different decking profiles here that you can choose from. Lots of different decking profiles. You've got reentrant corners, trapezoidal decks. You've got a range of different ones. Bond deck is something they use in Asia and in Australia and New Zealand. But you can just come and choose your preferred decking profile, and you can play with the parameters here, and you can accept that. Okay, now that's been set up. Now at the moment you'll see that this is actually, I want this to span the other way. It's spanning this way. I'm just going to flick this 90 degrees and have that span in this direction. So if I'm happy with this layout, I can just accept that, and then that gets created. And for the rest of the deck, I want them to be similar. So I'm just going to run around and create this, and you'll see it's creating the effective widths. It's remembered what we've created before, and it's just running around and keeping what we had. Okay, and we are just going to run around and set this up. So let's do that whole central panel as one. Okay, and again you can see it's just calculated the effective widths, and then we can accept these. Okay, let's come around and do that. Okay, I think I've missed one beam there. I might have to come back and put that in. Okay, let me do that. Yeah, let's grab that beam there, properties, and just put that in. Okay, all right. Okay, that's set up, and the properties. Okay. Let me just, I'll just for the purposes of making sure I'm right, I'm going to delete that, and then we're just going to go back and reinsert it. Okay, so let's just let's just go back and do this again. So okay, so you can see that I've done that. That's correct now. Okay, and then we can just run around and finish that. Okay, so very quickly you can see I've come and defined the deck. Okay, and we've put the slab in. Now, if you look at the 3D view, you'll notice that we're actually have dropped the slab, so dropped the beam. So the slab is now top of what we would call top of steel, or at that floor level, and we've automatically adjusted the the beams downwards, okay, to automatically adjusted them against what you would want as your slab finish level. Okay, so you can see that quickly we've been able to create that. Okay, that didn't take very long. Okay, now the final bit I'm going to show you today in terms of modelling is I'm going to go to the I'm going to go up to the roof. Okay, again I'm going to just let's just grab the stories, and I'm going to let's just assume we're at the 3rd floor, and I'm going to come and generate story to the 4th. And this time round, I just want to grab some columns. Okay, so I'm just going to copy these up. Okay, and we can hit OK, and then you can see that those columns have been extended up. Okay, now I could selectively choose what I want to copy, which probably would have been faster, but you can also come and just edit these and remove elements in here if you don't want to see them. Whoops, sorry, I didn't want to take those out. Let me provide those back. So let's assume that we've got some these columns here. Okay, something like this. Okay. Now, and I'll remove those ones on the other side as well. Okay. Okay. So I'm going to just at this stage take and I can work in plan as well. So let me just do that. I'm just going to select these columns here, and I want to go to the member table, and I'm going to go to the column table, and I want to extend the columns up. So I'm going to just change the DZ top, okay, and we're going to make this 2 meters, okay. So we can just type in a DZ top, and if I hit close, you'll see that I've now extended those columns up. Okay, so they've now extended up floor. Now I'd like to at this point come and create some trusses. Okay, now to do that I can just define a truss, and I can choose points where I would like the truss to span between. So I'm going to just drop the depth of this truss maybe to 1,000. Okay, we can put in the number of bays. Let's just assume it's 3. Okay, or maybe we can make it 4. Okay, it might be slightly better. Okay, now you'll notice here that there's a little preview. We've got a range of different trusses in here. You can import from CAD, or you can define them with nodes and so on as you would in, say, STAAD. Okay, I'm going to assign this to the top chord, so you can see it's removed the verticals there. Okay, you can play with splice positions. You can also play with fixities. I might want to pin all the internals in the truss, which I can do here. Okay, you can also introduce axial releases, torsional releases, and so on. So you have full control over all the fixities here. And if you're happy with this, you can just accept that, and that truss gets created. But what it's also done is it's remembered this, okay, and I can copy this, and we can replicate it to other elements. So you can just choose to quickly come and create and move those across to the other side. Okay, now I can do the same thing at the other angle. Okay, let's just come in and create that truss. Okay, it's remembered what we had. I can just accept that, and again I can copy that, and we can choose to replicate that across the. Oops, let me do that a bit ahead of myself. I'll just copy that one more time. Oops. To show you how to do this. So it's just copy command, and we've advanced these a lot with recent releases. So the steel is now extremely flexible when it comes to copying and creating. Okay, so I've just come and created some sort of edge trusses there. This could be a hall or sort of an auditorium, something like that. You can come and define this. What I may also like to do is just come and set up some purlins. So I'm going to just choose a couple of members. Okay, at the ends there, and we can define an arrangement. Okay, you can see a purlin arrangement here. You may be happy with this. Okay, you can put in sag rods and so on as well. But if you're happy with this, if you just accept it, then the purlins will get created. Okay, and I can repeat that on the other side. Okay, so we just choose those 2 end bays. It's previewing a purlin arrangement. You can manipulate this if you wish. Okay, and then they get set up and created. Okay, so I've just come and defined those. Now, I'm just going to come to the end columns here, and I'm just going to choose these end ones, and I can, if I go back to the tables, and this is where you can just manipulate things to suit what you want. I'm going to change the delta top now, and I'm going to increase this by another 500. So let's just make it 2.5, okay? And I can just hit OK, and you can see that we've made the connection here, but I've extended this up further, okay? And you can do things like this as you go about creating the model, okay? What I'd like to do at this point is show you a new feature, which is space trusses. So I can come and choose space truss feature, and you can define it by a series of points. So I'm going to just choose the actually what I will do to make sure I get this right is I'm going to do this in plan. I'm going to just come and choose the points and to set out the space truss. Okay, now we then have what we call a space truss generator, and you can manipulate this to suit what it is that you want to show. I'm going to show a slightly curved truss. Okay, I can key in parameters here, so I might make the this a little bit, the radius of this a bit different. Okay, and you can play with this. You can choose the number of bays that you want to have. Let's go with 6. Okay, I've got a bit of an offset, okay, which I'm going to use, and we can, if we hit generate, you'll see that it will create a profile here. Okay, so of course you can manipulate this to suit the geometry. You can also at this point come in and add loads to this. So very quickly, whether you're defining a sort of a space truss like this or a roof panel, you can quickly come and define these loads now. So if I had some additional superimposed dead load, okay, as well as some live load, okay, maybe that's 0.5 or something, these can be set up. Now if I hit OK, you should see that this will be established in the model here, and let me just show you that in 3D so you can see I've got quite a nice flash truss that we've set up in the model. Okay. You can use cladding as well for things like the purlins and walls where you may have defined these. So if I just click on those purlins, you can see that that's a cladding plane as well. Okay, and we can come and set these values as well. So you can put dead load and live load as well. Okay, and that will be set up and that will be assigned to that plane. So very quickly you can come in and load these up. So it's a nice way to be able to do those and define those very quickly. Okay, so again you can do this in here. Okay, 5 and maybe that's 0.5. Okay, something like this. Okay, so they get that set up. So we've got a model that's a little bit different. For sure, and we've got a funny space truss roof with some trusses. We've got a composite deck here with a composite system. I've shown you how you can go about creating a flat slab with drop head panels, and we've also got a sort of a conventional part of this as well. Okay, I'm going to do a couple more things, and then I'm going to get into the analysis and design. I'm just at this stage going to drop down to the first floor. And I'm going to just take these panels, and I'm going to just drop the walls, and I can just choose all of them. I could filter these, I can just select them like I'm doing. Okay, and if I go to the tables here, if we go to the wall table, okay, I'm going to drop the delta Z by, and we can do this on both sides. So let me just, let's just assume this is a meter down. Okay, and I'm going to do the other side as well. So let's just make sure that this is, we don't have sloping walls. So let's just drop these down as well. Okay, I'm just going to drop these a meter. Okay, so this could be you defining something like a lift pit. Okay, and you can just come in and set these up. So if I look at the 3D view now, you should see that the walls have now dropped below what would be the typical foundation level. Okay. Now you can, if I go back to the plan view, I can also take, and I'm just going to delete the slab here, this beam here for the time being, and I'm going to take this wall, okay, and I'm going to just model the model another wall in. So let's just and you'll see what I'm going to do in a minute. What I want to do is provide a wall down the bottom there as well. Okay, let's just assume the wall's spanning between these 2 points. Okay, okay, and I'm going to drop this as well. So we're going to the delta top. I've just got to we're going to take this as minus 3.6, and I'm going to do the same with this. It's minus 3.6. Okay, so what we should see now, if I come to this here, is you can see I've brought that wall down to that bottom level there. Okay, now of course we can take the properties of this, okay, and we can replicate this over here. So I can just come in and model that in as well. Okay, and we've created that. But what I also so you can see now that we've got a sort of a lift pit with some walls down there. Okay, that we've defined. Now back at this level, I can just come back and take the properties of this member, and we can just model a beam directly on top of this. Okay, I've just put a member in there that will support that slab at that higher level. Okay, so you can see now that we've got the slab up here, and then we've got the walls at a lower level there. Okay, so it's just one way that you could approach doing a model like this. Okay. Now I'm going to come down to the foundations. Okay, and let me just come down to the foundation level. So we can see that this has now been set at this level. And when I want to now define a slab, this could be a raft. Okay, and you can define the thickness of this in here. Okay, of course you can add additional loads. Okay, and I'm going to apply a delta Z. Okay, we want that raft to drop. I think it should be something like 650. Okay, so and I'm going to insert the raft by a beam region or an axis region. So you can choose how you'd like to do this. Of course, let's just assume that we've got the something like that there. Okay, so what I'm doing is just positioning that slab there. In fact, I've got to drop that a bit further, so I haven't quite got that right. So let's go back and change those. I think that delta Z is probably going to be what I originally thought, which was a meter. Okay, so again, it's easy just to edit. If you want to, you can just come and globally change things in here, and let's just make that minus a meter. Okay, and then we should be set. Okay, so I've just put it in at the lower level. Okay, we could, of course, maybe we've got a step foundation here. Okay, and we've got another part of the raft above. Okay, and again, we could come and define that in here as well. So I could choose to put another slab in here. Okay, we could maybe put it like a cantilever. Okay. Let's just assume it's a meter, okay, and then we could run around the edge here and define this, okay. Okay. So today I'm just sort of doing something a little bit different. I just wanted to give you an idea. So you can see here I've created something like this at the base, okay. So I'm doing something a little bit unusual. I just wanted to show you some of the new functionality in the release. Okay, we've got I've got a lift pit here with a foundation that's stepping. We've got our conventional beam slab system. I've got a flat slab. I've got a composite, and then I've got my roof and so on. So at this point, I could come in and assign other loads. So we can come and set up things like the seismic parameters. I can come and define different spectral curves. There's a range of different seismic codes that we support wherever you are in the world. This one happens to be for Malaysia, so there's seismic maps here that you can choose from. okay, and different ground types and so on. When you choose these will adapt to suit. Okay, of course you can key your own values in here. You can put in the number of modes that you wish to run. You can also define or different structural regularity checks you'd like to run. If you wish to do, or you're in a high seismic zone where you have to do strong column weak beam or joint shear checks, these can all be performed as well. Okay, and then you can just assign this to the model and that's set up. Similarly with wind loading, again, we will generate wind loads. Okay, you can define basic wind speeds. You can put in different topographical terrain factors to help generate the wind loading. Okay, you can choose the nature of the building, okay, and what type of thing it is, and then we will calculate all the pressures and crosswinds and so on, and they will be assigned to the model. So just with a few clicks, you can set up and assign different types of loading, wind loading and the like. They can easily be established in here. Okay. I'll just see if I can touch on no, I'll come back to it. Okay. So this gives you an idea. Now, at this point, I can check the model. So you can check things like the live loads that you've assigned, maybe the superimposed dead loads. If you want to check what column sections have I employed in the model, what beam sizes have I got. So all of this it's all color coded. So it's easy for you to check before you get to the analysis and the design. So the analysis is a button. Okay, what I'm going to do today, just in the interest of time, I'm going to just shoot to a model where I've already just run it. Okay, so this is exactly the same model. Okay, I'm just going to open this up. I just want to save a few minutes on running it. Okay, and then I'll take you through the results. So the same model that we've just created, and you can see what we've been doing here. Now, I've run the analysis, and at the same time I've done the design. So you can see the design status. You can see that this is a lot of this is passed. Okay, and you can see here that we've done a number of things. So we've designed the flat slab, and I'll come to this in a minute. Okay, we can see the full 3D results. We can come in and interrogate the model, the analytical results. So I'm going to just open up the analysis post-processor. Okay, obviously this is all integral, and you can come and review the results in here. You can look at things like, perhaps you're interested in looking at axial load for a particular combination. Okay, you can see those results here. Okay, you can see how they've been set up. Okay, you can review behaviours, seismic behaviours, and so on. You can see how the building's behaving under various excitation there. Okay, and in the different directions. Okay, probably not the most stable structure in the world, but you get the idea. We can move to look at other things. So if I wanted to look at perhaps some stresses in the structure, we can look at contours in the model. Okay, and you can look at different stress contours. Okay, I'm interested in maybe what I will do is I'll just focus in on the flat slab, since we were looking at that just now. So that's the level 2 there. Okay, and we can just choose to look at contours. For those of you familiar, you'll notice that we've now got shear contours in here as well. So you can just quickly come and review things like the shear contours. Okay, you can see axial stresses and so on, which are more pertinent to the walls. Okay, and you can see all the bending moments here as well. So we will resolve bending in X and Y. We'll also calculate the wood armour moments, and these will be resolved into design moments. Okay, so you can see these top and bottom in the different directions. Okay, these can also be represented in terms of area of steel contours. So you can get a feel at this stage what type of steel you may require. Now you'll notice, or you'll recall, that I cut strips through the model here. Okay, if you click on these strips, this is where you can see that we're creating points across which we are integrating. Now, if I select the strip and I right-click, you can see the strip profile. We're hiding the patches, so I'm just going to include the patches as well. So you can see the entire strip along this. So we will integrate across these strips, okay, and there's obviously various envelopes and so on, various that we're creating, all the pattern loading and so on is being run. But you can see the design envelope that we're using for designing this, okay. So that's another way that you can just come and interrogate the results and make sure that you're happy with what's going on, okay. When I ran the analysis, I also, and if I just show the whole building again, okay, and let me maybe, you'll notice that I also integrated the foundations, and these have also been integrated even though we've dropped the slab panel. So you can see that we've created an analytical model that represents that, okay. I didn't show you, but you can also define soil pressure loads and so on against those elements if you wish to. Okay, that's all part of the loading side of it, but you can see there that we've just built this complete model here. Okay, okay, so let's just delve in a little bit more into the model itself. Okay, so we've designed, I'll just turn off the analysis model for a minute. Okay, so we've designed a number of different elements in here, and to access these, we can come to the design. So all the elements that we've modeled are all accessible in terms of design in the menu here. I'm going to go to composite design. Okay, you can see that these have all passed. And if you want to dig down into a member in more detail, you can just select that member, okay, and you can have a look at this in more closely. So you can see that we've laid out the stud arrangement there, and there's been a number of different checks that we've performed. So this is just a very brief summary of the checks. So things like shear, longitudinal shear, camber, shear buckling. You've got serviceability checks in terms of deflections as well as vibrations. All these will be checked. So you can see just a preview of that here, but what we also will do is provide you with detailed design reports. So you'll see that in this release, there's comprehensive documentation now of all the designs. So if I select, say, a composite beam, you can see in detail all the various checks that we're performing, okay? And you can see there was various headings here, so you can look at different parts of the checks. So for composite, there's a construction stage that we will need to run, as well as a final composite stage. So we're running these analyses simultaneously. As it runs the analysis, it's running both cases simultaneously, and you can see the various checks that we're performing for this. We'll also be checking for shear, okay, longitudinal shear and so on, bending, camber checks. There'll also be so various checks, and you can see all the detail against the code, step-by-step calculations here. Okay, you've got some final deflection checks, as well as general checks as well. Okay, there's also checks for, there'll also be checks for, there are also checks being performed for vibrations and so on as well. Okay, that'll be part of those checks that we do. Okay, so that just gives you an idea of the composite design. Okay, they're designed. If we would like to look back at the flat slab, okay, so you can see that these have been designed, and if we go to the slab design, these are automatically designed as part of this. You can click on an item here, and we will open it out. So you can see the main strip, and we've laid out longitudinal bars along the main strip, but for each of the head zones, we need additional steel, okay? I probably haven't provided the best example here, but there'll be additional patch steel required across those column patches, okay? And you can see this in here. So you can see, and you just review these, you can see where we've got additional steel required, okay? And there's detailed checks that we're performing, okay, that you can see this in more detail. Okay, there are reports, so these will be summarized as a report, okay, and you can just get a very brief summary, or you can look at it in detail. Okay, and you can also examine the strip profile like I was doing earlier here also. Okay, now in addition to these checks, you'll also want to be checking for things like punching checks. So if I choose the columns here, okay, let me just grab a column. Okay, you can run your punching checks. Okay, we will know what's in that vicinity, okay, and it will do the check. So it's checking this to Eurocode, but if you're using say the US codes or perhaps the Indian standards, there'll be detailed checks performed to satisfy the code here, okay, and they'll all be documented as well. Okay, now that includes the pattern loading. Of course, when you run the flat slab, if you're doing a subframe or part of the building analysis, you can make adjustments for creep and shrinkage. We also have, in this version, there is also deflection checks as well for slabs. You can cut additional FE strips through this, and you can perform very detailed, rigorous deflection checks of these, looking at creep and shrinkage over time. Okay, so you can set up limits, okay, and we will check it to the code. Okay, so you can see those checks in there. They're quite useful, and they also can be used for beams as well. So if you're looking at long term, maybe you're worried about displacement. It could be part of the structure that you don't wish to have excessive deformations. You can just use this to check, okay, and there'll be sort of quite rigorous checks by first principles. Okay. Now, I had also so let me go back to the model again. So we've also done the steel checks, and again you can click on the steel member design for say the roof here, and you can see for this for our space truss, you can see the checks. You can see detailed checks for the different elements, okay, and you can drill down into these. Now we can provide detailed reports, and again you can see very, very detailed checks against the code with step-by-step documentation for each of the elements. So whether it's a space truss like this, or just a general trusses like over here, again you can access these detailed reports in the software, and you can see all the documentation behind it. You can come in here, you can manipulate these if you want to change things to get design to pass. Perhaps you haven't modeled all the purlins and you want to manually edit the buckling parameters, you can do that as well. Okay, all of this is at your fingertips. You can just come in and tweak things to suit what it is that you your assumptions, your engineering assumptions. If we go to the general design, okay, so all the columns and walls here have been designed, and you can click on a column or wall. I had actually merged, in this particular model, I'd merged the walls, so you can see that these are now being designed as one element, and we will collect the forces as one singular element, and we will design this, and you can see we will calculate the neutral axis of the core wall there, and we will design it accordingly. You can also see detailed interaction diagrams. So these are, I'll probably show that best with a model. We're also, even at this point, starting to look at how this would be drawn out. So you can get a feel for how that wall is going to be drawn out with the end zones and so on, just with a click, okay? And you can start to get a feel for how this is going to be ultimately designed and presented, okay? So the columns, similarly with the beams, okay, the beams are all designed there. You can group beams, so we will automatically group similar axes, okay, and it will find those members that are similar, okay. So these have been grouped, and then if you click on a particular beam, okay, you can look at the results in more detail, okay. Let me just open up. Let me come down, I'll just grab a beam from the, you can also interact with the model here, so you can come in and have a look at this in more detail, okay. So here's a schematic of the beam, okay, and you can see the rebar on this, okay. This is when at any stage you can make changes. When I drop the steel there, you see that this is not adequate, okay, and so this is interactive, but we're trying to optimize the rebar for you. We have detailed reports here also, so you can see now step-by-step design calculations for all the concrete beams, elements here, so you can see exactly how we've come out with the design. Okay, we're not leaving anything to chance now, so if you want to drill in and look at a lot of the detail around the code, we're checking for things like shear and torsion. There's detailed deflection checks as well are being performed. So all of those you can see the documentation for here, okay, if this is the level of detail that you want. Of course, most of the time you might just want a brief summary, and you can just get a summary report there as well, and that can be created. Again, in here you can look at diagrams, so you can see the envelope that's being used for design. You can also get a quick look at how the drawings are going to be prepared. So here you can see that beam detail, and you can just get a quick glimpse of how the final detail may look like. Okay, so I've covered a bit of the design there, so you can understand how this is being designed. At this point, I might want to just come back down and to the foundations again. We have obviously modelled the foundation in this vicinity. Okay. But what I'd like to do at this point is go to the perimeter columns, and I'm just going to select these, okay, and if we just select the perimeter columns, if we right click, in fact I might let's do a variation just to show you. Okay, so maybe those end columns, okay, maybe they don't have so much load on them, so I may want to just insert pad bases. So you can just right click, and you can ask it to design the pad bases. So it will take all the combinations that have been run, and it will go through and size up the pad bases. You will define the allowable bearing pressures, and it will come in and size them. Now these can be grouped, okay, okay. Let's have a look. Group selected. I haven't selected all of them. Sorry, you can rationalize these. You can group. I'll show it with the pile caps. If you hit OK, they get created. Over here, I'm going to come and create the, if I just choose these perimeters here, for these elements, I'm going to, instead of them being, let me just grab that column, and this one down here, let's get that as well. That one, right click. So this time around, I'm going to insert pile caps. So in here, you'll define arrangements here. Okay, the foundation settings, you can define your allowable, maybe you've got an ultimate compression capacity. You could put your pile size and the spacing that you want, so you can just set this up. Okay, and then you can ask it to design them all. So this has been designed. Okay, again, these can all be grouped, so it will find those that are similar, and they've been grouped here. And if you hit OK, you can see that your pile caps have been created. Okay. Now, if you find on site that piles are getting a bit, yeah, they're not where they're meant to be. Okay, and you want to just come in and interrogate these. So we just so you can see the piles here, the pile locations. All of these are editable. So if you found that a pile moved, you can key in the eccentricities. Okay, and we will check to see whether that's okay or not. You can see there that maybe I've got to just, maybe I need to increase the steel. So you can come and manipulate this and work with this and try and get this to pass. So you can just play with the arrangements here to see whether this this can be. Let me just up it a bit more and see if, yeah. So I've just tweaked that to make that work. Okay, and then maybe then that's my as-built pile. So you can see the as-built pile position is now being presented. Okay, so sort of quickly we've done sort of an interesting building, a little bit different from convention, but I just wanted to take the time to show you how you can employ and use these different structural systems in practice. At this point, the final thing I might want to do is just come and create some of the documentation around this. So I'm going to load proto details, okay, and I'm just going to save this. It will load up Proto Details, and we'll start to document out some of what we've created today. Okay, so just give this a second. It will launch. Now, Proto Details is part of our documentation tools. It's a complete CAD system. You can happily draft in here. It's set up for structural detailing. Okay, and when you launch Proto Details, okay, you'll be able to you can just use the auto generate commands in here. I'm going to auto generate. Now it'll ask me what I want to draw. I can choose. I'm going to insert them to a sheet. I can come and choose a title block. So this would be your standard title block. You can play with the scale, the details here. You can play with things like how you want the beams truncated in the sheets. All this is at your fingertips. And once you're happy with this, you can then just ask it to draw. So it's going to go away and take those, take what we've created, and then it's going to place them into our drawing sheets. Okay, and just give this a few seconds and let it generate, and then you'll be able to see how all of this looks. Okay. Now you'll notice that it's a DWG file. Okay, so it's just a seamless transfer out to AutoCAD if you wanted to, or other drafting platforms if you wish to communicate with those. Okay, in here you have full control over everything, all the layers, the line types, everything's within your control, and you can work with this in the model. So a few more seconds and we should be done. Yep, okay, so we've finished. You can see if I just zoom out, okay, we've created all these drawings from that model just with a click. Okay, you can see our key plans here, okay, foundation drawings with the pile caps and so on, okay, are being drawn out, our raft foundation. Okay, here you can see various key plans. Okay, this is our flat slab with the drop head detailing. Okay, you can see the composite systems here, number of studs and so on. Okay, you can have set out drawings against grid if you wish. Okay, you can also draw things in elevation. So here you can see I've got my core walls, and you can see the end zones being drawn out. Okay, you can have column elevations if you wish to provide that those types of drawings. Maybe you just want to provide schedules, so you can see the schedules here. We will automatically group similar columns for you. Okay, they'll be created. Okay, and so you can see all the grouping has been set up here. Okay, as well as the core walls. Okay, so you can see those being drawn. For the beams, okay, they're also provided. Similar beams will be grouped. Okay, and you can see the grouping here. If a beam gets too long, like in this situation here, we'll automatically truncate it. It'll carry on and continue to detail out. So you can see we've just neatly been able to arrange all these beams into this sheet. Now, if you do look at the sheet and you look at this member here, for example, there's 3 H12s. It's positional mark 1. If we come over to the table here, you'll see that for positional mark 1, the 12s, there's actually 44 of those. They're 4.2 meters long, 228.8 meters in total. Here's the bar bending schedule. Okay, and you can see for this particular drawing, there's about 1.82 tons of steel. That includes everything, all the laps, the lengths, everything's been calculated in here. If you want to, at this point, with this release, you can actually just select those tables, and if you go to export, you can dump these out to Excel. So if you were, maybe the client's asking you to do some quick estimates on a job, okay, you can just put in some costs here and you could price that out. So that's a nice new feature that's come in. Okay, you can just export things to Excel with a click, and then you could provide some insight into the cost for the job. You can present these in a schedule form if you don't want to provide that level of detail. And again, you can see your foundation drawings here, your pile caps, as well as your pad footings. Okay, they're all being drawn up as well, and they're also being all fully quantified. Okay, you are, as I mentioned, in CAD platform. So if you do want to just, if you didn't want to have, if you wanted to tweak things, and maybe you didn't want that detail there, and you just wanted to pick it up and move it somewhere else and place it elsewhere in the sheet, you can. It's entirely up to you. You're in CAD. If you wanted to Maybe you wanted to bring this detail and provide it somewhere else. Okay, forgive me, I'm not the best CAD technician in the world, but you get the idea. If you wanted to bring this in, you could. If you want to do things like truncate a member, maybe you'd like to slice the member at some point and bring it down. Yeah, there's smart things going on in here. It knows what the size of the members are. They've been repeated. The links have been repeated here. The member references have been repeated. So it's easy for you to understand what's changed. And there's just tools in here that can help you with the detailing. Okay. So that gives you an idea about how Product Details works with the documentation. Okay. There's an array of other tools in here that you can take advantage of. So you can create new sheets, and you can just pull off certain information that you want. If you wanted to draw up, for example, a shear wall elevation all the way up the building, okay, and you just wanted to create, that's probably not the best one in the world to do. That was my short wall. Let's just see if we can draw a complete elevation of that main wall up. Okay. You can see that core wall all the way being drawn all the way up the building. So you have tools in here where you can just grab what you would like to draw, and then you can just place it into your sheets, okay? And you can just arrange things, okay? Now we do have library of design in here. So if you want to design other things, maybe on the model project, you've got staircases, different types of stair arrangements. You can design these. We will produce all the detailed design reports, but we will then create the documentation for this, so you can see the stair detail being produced. There's an array of other calculations in here, things like retaining walls. Again, you can come in and set these up. You can do things like sloping backfills and things like that can be set up. You can design these with a click of a button. We'll do things like slip circle analysis and so on. Again, there'll be detailed documentation for this, and then you can create the details with a click. Okay, so you can explore these in here. We're increasing the number of components in here that you'll see as we move forward. This library will expand out. So if you just want to design things quickly, you have these available in here as well. Okay. Okay, so I know that we've covered quite a bit of ground today, and I really just wanted to focus in on some of the new capabilities that we have with ProtoStructure 2025. I'm not going to dive into ProtoSteel today. There are a lot of other videos available on our YouTube channel which go through that in a lot of detail. You can see the real power of automated connection design and steelwork detailing. I just wanted to stop at this point, and I hope you found what we've covered today informative and interesting, just engaging and employing the new capabilities of the system in a structure, and just showing you guys how you might be able to take advantage of this on your particular jobs. I know this is a little bit of a unique building, but of course I just wanted to give you some insight here. Okay, so just to finish then, just to quickly finish, for those of you who want more information, please check out our Help Centre. There's a wealth of knowledge here covering all aspects of the program, all detail around how you can take advantage of it, design guides and so on, covering many of the new features that you've seen today. Also, of course, don't forget the YouTube channel. We're continually publishing new things in the YouTube channel. There's also white papers that we create. So these will detail design papers that we publish that cover various technical aspects of the software. You can look at how we've implemented the code in detail. So we've got comprehensive coverage here from the US codes to the British and Euro codes, right through to the new Indian standards that we've introduced. So check that out. There's lots of, if you're interested in, and even if you're just interested in learning about how to go about assigning seismic loads and things like that, this will be quite informative. We have the YouTube channel. Please subscribe. Yeah, we're we're wanting to get up to about 25,000 subscribers in the next few months. So if you jump on that and click the like button, that would be great. We're constantly publishing new content, including this webinar, which will be available after we publish it. Please reach out and connect to us on our social media platforms. We're on LinkedIn, YouTube, Facebook, Instagram, and X. If you're interested in acquiring the platform, I know that there are some special offers going on with Black Friday this week. So if you are interested in the platform, please get in touch. We'd love to hear from you. If you are in most of the world, it's globalsales@protosoftware.com. If you're down in Asia, the Asia Pacific area, please reach us at asiasales@protosoftware.com. You can also, of course, interact with us through the website. Drop us your contact details, and we'll be in touch. So I'd just like to, on that note, thank you very much for today. It's been great, a real pleasure having you. Thank you for your attendance. I hope you found today's session useful, and we look forward to bringing you great technology, for introducing more and great technology in the years to come. So thank you very much.